Earthquakes are one of the most powerful and destructive natural phenomena on our planet. They are caused by the movement of tectonic plates that make up the Earth's crust, which can result in significant ground shaking and sometimes cause damage to buildings and infrastructure. Earthquakes can occur anywhere in the world, and their impact can vary greatly depending on factors such as their magnitude, depth, and proximity to populated areas. One of the most important factors in determining the impact of an earthquake is its magnitude. Magnitude is a measure of the size of an earthquake and is one of the most important factors in determining the impact of an earthquake. Earthquakes are typically measured on the Richter scale, which was developed in the 1930s by Charles Richter. The Richter scale is a logarithmic scale, meaning that an increase of 1 unit on the scale represents a 10-fold increase in the magnitude of the earthquake. The magnitude of an earthquake is determined by the amount of energy released during the event. This energy is measured by seismologists using a variety of instruments, including seismographs, which detect and record the ground shaking produced by the earthquake. The magnitude of an earthquake is then calculated based on the maximum amplitude of the ground shaking recorded by the seismographs. The Richter scale is logarithmic, which means that a magnitude 7.0 earthquake is 10 times more powerful than a magnitude 6.0 earthquake and 100 times more powerful than a magnitude 5.0 earthquake. The largest earthquakes on the Richter scale typically have magnitudes greater than 8.0, while the smallest earthquakes are typically less than 2.0. Magnitude is a key factor in determining the impact of an earthquake. The magnitude of an earthquake can influence the extent of ground shaking, the size of the area affected by the earthquake, and the potential for damage to buildings and infrastructure. For example, a magnitude 7.0 earthquake can cause significant damage in a densely populated urban area, whereas a magnitude 3.0 earthquake may not result in significant damage or casualties in a rural area. Another important factor in the impact of earthquakes is their depth. Earthquake depth refers to the vertical distance between the earthquake's focus, or the point of origin within the Earth's crust, and the Earth's surface. Earthquakes can occur at various depths, ranging from shallow to deep, and their depth plays an important role in determining their impact and the resulting damage. Shallow earthquakes, with a depth of less than 70 kilometers, are the most dangerous and destructive because they affect a larger area and cause stronger shaking at the Earth's surface. The shallow focus allows seismic waves to reach the Earth's surface with higher intensity, causing more damage to buildings and infrastructure. Intermediate earthquakes, with a depth between 70 and 300 kilometers, are less destructive as the seismic waves generated at this depth are absorbed by the Earth's mantle. However, these earthquakes can still cause significant damage in the regions directly above the focus. Deep earthquakes, with a depth greater than 300 kilometers, are the least destructive as the seismic waves generated at this depth are absorbed by the Earth's mantle and core, leaving only small amounts of energy to reach the Earth's surface. These earthquakes are also the least likely to trigger tsunamis. The depth of an earthquake is determined using seismological methods, such as analyzing the arrival times of seismic waves at various seismograph stations. Seismic waves travel at different speeds through different layers of the Earth, and the speed of the waves provides information about the depth of the earthquake. The proximity of an earthquake to populated areas is also a key factor in its impact. Earthquakes that occur in urban areas can cause significant damage to buildings, roads, and other infrastructure, whereas earthquakes that occur in remote areas are less likely to result in significant damage or casualties. In addition to causing damage to infrastructure and buildings, earthquakes can also result in other secondary effects, such as landslides, tsunamis, and fires. For example, earthquakes that occur near the coast can trigger tsunamis, which can cause significant damage to coastal communities and result in loss of life. Similarly, earthquakes that occur in urban areas can result in fires, which can spread quickly and cause additional damage to buildings and infrastructure. Despite the potential for significant damage and loss of life, earthquakes are also a source of valuable scientific information. One of the main ways scientists use earthquakes to study the Earth is by examining the seismic waves that are generated by the earthquakes. Seismic waves, also known as seismic energy, travel through the Earth and are recorded by seismograph stations on the surface. The different types of seismic waves, including P waves and S waves, travel through the Earth at different speeds and can be used to determine the Earth's composition and structure. P waves, also known as primary waves, are the fastest type of seismic wave and are the first to arrive at a seismograph station. P waves are compression waves that move through the Earth's interior by alternately compressing and stretching the material they pass through. Because P waves can travel through solid rock and liquids, they are a valuable tool for studying the Earth's inner structure. S waves, also known as secondary waves, are slower than P waves and arrive at a seismograph station after the P waves. S waves are transverse waves that move perpendicular to the direction of wave propagation, and they can only travel through solid material. S waves provide valuable information about the Earth's crust and mantle, and their behavior and arrival times can be used to determine the Earth's composition and structure. By analyzing the arrival times of these seismic waves at seismograph stations, scientists can create a seismic tomography image of the Earth's interior. This image allows scientists to see the Earth's structure in 3D, and can provide information about the Earth's crust, mantle, and core. Another way scientists use earthquakes to study the Earth is by analyzing the patterns of earthquakes that occur over time. By studying the frequency, location, and magnitude of earthquakes, scientists can gain insight into the Earth's tectonic activity and plate movement. For example, earthquakes along plate boundaries provide information about how plates are moving and interacting with each other, which can help scientists better understand the processes that drive plate tectonics. In addition to studying the Earth's structure and tectonic activity, earthquakes also offer scientists an opportunity to study the Earth's surface and the effects of earthquakes on the environment. Scientists can use satellite imagery, ground-based observations, and other data sources to study the changes that occur on the Earth's surface after an earthquake, including changes to landforms, waterways, and vegetation. This information can help scientists better understand the impact of earthquakes on the environment and can inform disaster response and mitigation efforts. Finally, earthquakes also offer scientists an opportunity to study the Earth's history and evolution. By analyzing the ages of rocks and minerals that have been disrupted by earthquakes, scientists can gain insight into the Earth's geological history and learn more about the processes that have shaped our planet over time. Earthquakes are a powerful and destructive natural phenomenon that can have significant impacts on communities around the world. Despite the potential for significant damage and loss of life, earthquakes also provide valuable scientific information and help us better understand the Earth's processes. By continuing to study earthquakes and improve our preparedness and response efforts, we can help protect communities and reduce the impacts of future earthquakes. If you enjoy our videos, don't forget to like and subscribe. Thanks for watching, and stay in the know.